Okay, so we were told to start our presentation here. Hi, my name is Moti Goldklang. I'm Director of Trading R&D in eToro.
I'm Ronen Almog, Director of Data Science and AI at eToro.
Just a second, this doesn't work. Backwards, forwards. Okay, we're here to talk about harnessing the power of AI and the wisdom of the crowd in trading. Quite a dramatic title here. On eToro, our vision is to open the global markets for everyone to trade and invest in a simple and transparent way. We're trying to do this, or actually doing it, by building the world's leading social trading network. We'll go through the product real quickly, and then you'll see where we focus our ML efforts today. Some numbers, generally speaking, we have more than 10 million registered users in more than 140 countries. We have a significant trading floor going through our systems. And during the last couple of years, growth we had in our company, we got into 650 employees, more than that these days, and raised quite significant capital, just for the sake of understanding who we are. Our customer's journey in our platform starts in the Trade Markets tab. On our platform, buying Bitcoin or crypto is as easy as investing in an Uber stock or as investing in the Chinese markets, all in a very simple way. On top of that, we've built a social network. Each customer and every instrument in our system has its own public page where you can find discussions over their markets, performance, market predictions, portfolio management strategies, and so on. We find a lot of interesting information going down that path. And on top of that, we've built what is our flagship product, which is CopyTrader. Every customer in our social network has its public profile, where other than past performance, obviously normalized, not actual numbers, but percentages, you can find this past performance over time. You can find how many people are already investing in him. I'll get to that in a second. You'll see his risk profile over time. You see his current portfolio allocation. You can also look at his past performance and past portfolio allocations. And if I find someone that, according to my understanding and what I'm trying to invest in their correct markets and has a very good returns over time, and I don't know, I like his profile picture for that sake, I can take, for an instance, $5,000 and invest in that person. So from that point on, the system will automatically copy this customer's investment strategy into my $5,000 investment. For example, if he was going to take 10% of his equity and invest it in Google, we're going to take $500 pretty much out of your equity and invest it in Google as well. When he closes his position, we're going to close yours on the same prices, and you're going to enjoy the same returns that he did. That's like the general thing about copy. So over time, we saw significant growth in our system. This specific product was quite an earthquake in the financial investment world. But going through the system and taking a decision who you want to invest in became quite dramatic or quite hard for our customers. Because there's a lot of people, a lot of different trading flavors, and investment and profile management strategies. So for each customer to go through potentially millions of profitable portfolios and choosing who's the right one for you to invest in, even if you're building a diversified portfolio, is quite troublesome. So this is exactly where our project kicked in, and this is what we want to share with you today. We call it Copy Portfolio. It's basically eToro's ability to look at the entire data set that she owns and try to classify who are the best traders we have and build a portfolio that copies these specific traders. So people who invest in that portfolio will be automatically exposed to the best people we have on our platform. So as I said, eToro's different products and different talent in the system are generating a lot of interesting information and data sets that can later be learned and be used to build different portfolios and risk management strategies. So if you look at from a more definitive perspective, so it's a copy portfolio which beats the markets. Obviously, want to build something that makes money and that people want to invest in, and nothing much to add here. So the potential is quite obvious, as I just mentioned earlier. We had a lot of interesting information going through our systems, whether it's the trading flow itself and the different aspects of it, the demographic of the traders themselves. We own that data; it's ours. The performance, the statistics, the actual financial or market data, we also have it as well. The social network test feeds, all the market predictions, all the definitive portfolios or strategies that people are sharing with the community can be later on be used to understand how much talent is inside each and every customer. And of course, the social network relationship, it is a social network that's people following each other, interacting with each other, having comments or prediction over specific markets, which can later be used to understand who has a better talent in a specific market, for example. So we started playing around with our data and modeling it. We took a 1-year data of customer. We initially started with this set of feature vectors, we call it. Whether it's the past performance, a quarter-over-quarter gain, standard deviations, drawdowns. We took their level of activity with the platform, how much do they log in, how much do they interact with the community on our social network, their equity in comparison with other customers on the platform, the seniority level, how much time have they been trading on our system, and risk factors. We have a mechanism of a risk score in our system. We can have a complete talk on that as well. And what we're trying to predict here, which is our label, is whether this specific customer is going to have a positive return during the next 30 days. So technically speaking, if we're thinking about the portfolio or the product we're trying to build here, is that every month we're going to choose according to past performance and different derivatives of it, who are the best traders to invest in, and then we're going to invest in those people. 30 days later, we're going to rebalance that portfolio. So eventually we'll have a winning product on our hands. So Ronen here is going to talk about the distributions in our data and what we're trying to focus, and then we go back to what we did in order to tackle this problem.
So we have a lot of data of the user performance. For example, if we look on the yearly gain we define the profit or loss divided by the initial invested amount. So it's how your money multiplied from the beginning of the year to the end of year. And if you look on our data, for example, for 2017 and 2018, you can see that in 2017 there were people with a gain of 20, for example. How did they do it? By, this was the Bitcoin explode in 2017, and the people that used to invest in Bitcoin did very good. Also, you can see that the distribution of the yearly gain is very spread. It's exponential, and our target is to locate or to find the best people. So we are going to build, and we build models that trying to identify and predict who will be the people with the highest gains, as you can see here. So who will be the people with the extraordinary gains? In 2018. People has little bit, less. It was a harder year. Bitcoin crash, all the cryptocurrencies, the exchanges with the normal stocks and Nasdaq, for example, did not so very well. So you can see the gain in 2018. Still, you see that there are people with very good gains, and we have models that are locating these people. This is, for example, a plot of the drawdown. Drawdown is when you look on the cumulative P&L and you locate the depths between peaks and valleys. And you can see that there are people with a relatively small drawdowns. They know how to manage their money. And there are people with 100% drawdown, which basically they were wiped out. This is a nice histogram of the activity of the user. So this histogram measures the activity by the average number of logins in 1 quarter of users. You can see this is very spread. There are very active users, and there are users that are not active. And our challenge is to find among the active users who will be the best. That's a nice distribution of the user success rate. So when we took the positions which were open in 1 year, and we look on a certain position of the leading instrument, the indexes, some leading indexes, commodities, and stocks, and when we take all these positions, for each position, we look on the success rate, the percentage of success rates that the user had, and you can see this distribution of success of positions by the user success rate of the positions, and you see again, you can see that there are positions which are positions of very good users, which is in this part here, and the challenge is to find the good traders with a significance, a good statistical significance. So as Moti mentioned, we have two kinds of operational trades. We have manual trades and copy trades. This is the distribution of the different kind of trade. So you see that the copy trades are about 84% of the trades that users are opening are copied, are not manual. They are copying other people. This is the distribution of the profitable trades.
Okay, so in order to measure our performance of whatever model we're trying to build here, we built a simulator to backtest our data. Our main focus is currently marked here is the gain from one hand. Obviously, no one's going to invest in something that doesn't make money, so our business gain target is quite critical here. And the precision on the other hand. The reason that we don't care about recall or accuracy is because A, we don't really care about finding all the people who make money in our system. We just want to make sure that the people we do choose and invest in our investment portfolio are going to make money. Same thing goes for accuracy. We don't care about the people that we mistakenly classified them as not making money, because again, we care about precision here. Other things we're looking at here when we measure our performance is different, more domain-specific metrics, such as standard deviation of the portfolio over time, Sharpe ratio, which is the ratio between the standard deviation and the gain, the other way around actually, drawdowns over time, and the benchmark comparison. So in this specific case, we had a question which benchmark we should compare ourselves with. The reason is because each and every customer we put inside our portfolio doesn't have a very definitive strategy. He can, technically speaking, he can choose whatever he wants to invest in and change his allocation over time. So it's not really a very deterministic index that we can, or benchmark we can compare with. So our business experts or domain experts in our company just chose the S&P 500 for that sake. So this is the line right beyond, underneath the second line here. And actually we're looking at what's it called, the margin or the equity over time of our fund and our exposure. So we started playing with the data. We're starting to build, to use those features to create an initial model. Of course, using the population that Ronen mentioned, we're trying to focus on, whether it's customers with a specific drawdown or up to a specific drawdown, customers with a certain amount of gain, not too risky on one hand, but again, something that makes money, and some level of engagement with our system. And what we ran into is something that we call internally seasonality. It's not the classic seasonality definition that people usually talk about in the financial markets, where it's the reoccurrence of phenomenons or the cycles in the markets. It's what we call, what we relate to is the importance of the time frame that you're trying to model as compared to the time frame you're trying to predict. We saw that quite clearly when we did an initial data split on our data. We took a one-year data of our customers, as I said before. We did a classic machine learning split of 80-20%. And what we saw, we got these amazing results. at the beginning, obviously. You can see, for example, on this precision recall curve that around 50% recall, you get more than 90% precision. Like every single data scientist in the room should say, okay, there's probably a data leakage here. But we were happy. It was the beginning of a roadmap, and we thought, okay, we have very indicative features under our hands. But when we took this one step further and we actually thought, okay, so how are we going to use this kind of thing in production? We understood that we're going to learn a complete year of data, but then we're going to predict the following month. So it's not like the classic 80-20% learning. In this case, we use an XGBoost model here. If I remember correctly, it was 100 trees with 0.01 learning rate, if someone cares. And the results was obviously completely different than the initial experiment that we did. What we should focus on here is the fact that the precision dropped to pretty much flipping up a coin, and even less than that. And if we're looking at the portfolio performance over time, there are a few things we had to put our mind into. We see that the performance is very volatile. You can see that there's a rise up to 150 over there, and then just a small dropout. You can see that if we look at the different cache portions over time, you can see there are 3 or 4 places that the cache is taking too much portion in the investment strategy, which is a very bad investment experience. When you put money in a fund, you expect it to work. You expect it to make money. In our case, there's portions of time where the balance portion or the cash portion is too high. So we had to tackle this exact problem. So the first thing we did to play with the data, we thought, okay, let's tackle the seasonality. Let's build an XGBoost model for every month over that year period. Same parameters, by the way. And what we saw is a couple of things. We saw that the precision didn't move a bit, which was quite disappointing. But the gain dramatically increased. So we were able to detect, technically speaking, we don't have much time. We were able to detect people who make more money, let's put it this way, or somewhat riskier. But the other stuff here, which is the variability or the cash equity, didn't change much. Am I missing something here? No, not about it. So we had to drop a bit deeper into the volatility thing. When we took the different components in our system, in our portfolio, we saw many portfolios or strategies, which pretty much looked like this: a very volatile, going down, going up afterwards, but eventually finishing in a good place. So what we did was a quite simple but interesting method here. We took every customer's equity graph, and starting of the end of it, we took back day by day and drew a regression line from it. Until we got to a point where an F statistical test to determine the lack of fit, we used it in order to determine the breaking point, or where is the actual regression line that best projects the customer trajectory or current gradient. Later on, we limited that gradient line to 0.07, if I remember correctly, to have people that are not that risky. People have like a pretty nice increasing slope, but nothing that is too risky. Eventually, in order to take the people who are the most stable over that regression line, we used R-squared in order to take the people with least residual over the regression line. So we did an intersection between the ensemble model I talked about earlier and the momentum line here. We got a dramatic increase in the precision, which is good. Finally, we have a model that actually works. But we saw a dramatic decrease in the gain. And the reason for that is quite obvious. If you take more stable people and you take less risk, then you'll see the potential of the gains or the returns is lower. So the last thing we want to focus here, obviously there was a lot of things we handled during this project, was just the thing that we wanted to talk about here. The last thing we want to talk about is, again, the balance portion of the portfolio, which is related to a mechanism we have in our system, which is called copy stop loss. Just a few words about it. When people invest in copy inside eToro's platform, we saw a very recurring phenomena where people put their entire money on customers that the past performance were very good, but then at some point in time, they just lost all their money, and the total social network lost a tremendous portion of it. So what we did, we built a copy stop loss, which is a very interesting engineering effort on itself, an algorithmic effort on itself. But the copy stop loss basically determines that if your investment in copy drops under a specific level, then we're going to put the plug on it, and you will not lose more than a determined amount of money that you specified. So what we saw when we looked deeper into our portfolios that are currently managed, this is like a pretty short amount of time, we saw that there's a lot of people rebound back after their initial investment. So even though eventually they're going to finish in a good place, we cut them out too early. So what we did in order to give those people a chance is to basically measure the standard deviation of each customer and fit the copy stop loss of each customer accordingly. So if a customer is used to invest in a higher standard deviation portfolio, then we'll give them more place to rebound back than people who are usually very, very stable over their equity curve. But on the other hand, when there's a drop, it's supposed to be a sign. And the results, again, were quite interesting. So here the precision increased a bit, again, which made our confidence in our model increase as well. But again, the gain dropped, which is obvious because we gave more people the ability to take a larger risk, but as you can see, the bullish portion problem was solved, and we were all happy. Which again leads to the same maybe potential on one hand, at least product potential of building multiple portfolios and strategies and flavors of that problem. But there's always a risk and return trade-off here. So on one hand, I'm pretty sure everyone's obvious with it, you take a larger risk, you have a better potential of winning, but then again, you have larger potential of losing as well. Ronen can talk about the next steps in our project.
So next step is to use a different combination of the ensembles that we use in our models. We have a social feed, so we are going to analyze the social feed by NLP and then take these features from the NLP of the social feed into our models. We are going to use time series analysis by deep learning like LSTM methods and statistical methods like ARIMA, GARCH, and so on. And we are going to go inside social physics. We are cooperating with Dr. Yaniv Altshuler from ENDO, and we are going to use some of his algorithms to see correlations and connection between users and use it as features in our models. And if you are interested in challenging work in fintech, in investments, so you are welcome to join us. Thank you.